Hi students, welcome to the session. I am Dr.K.Varada Rajkumar, Associate Professor, Department of CSE-AIML, MLR Institute of Technology, Hyderabad. In our previous class, we discussed about linear search. In this class, we will learn about the binary search algorithm. So, overview of the session. In this session, so first we discuss about introduction to binary search algorithm. So after that we discuss the algorithm. So after that we discuss about the time complexity of binary search algorithm, and finally we discuss about advantages and disadvantages in binary search algorithm. Outcome of this lecture, at the end of this lecture, you all are apply binary search algorithm to search an element in a collection. So what is binary search? So binary search is an efficient algorithm for finding an item from a sorted list of items. Okay, you all remember, for binary search the input must be in sorted order. So what is binary search? So binary search is also a searching technique. So this we are going to use to find an item from a list, but the list must be in sorted order. Okay, so let us assume, so this is the array. So let us assume this array contains 7 elements: 0, 1, 2, 3, 4, 5, 6. So this is the array name A. So here the input must be in sorted order. So 9, 19, 25, 32, 45, 58, 99. Okay, now so let us assume the target is 58. Okay, so now so every time the 58 is compared with mid element. So here the mid value is 32. Now I compare 58 with 32. Okay, if it is a linear search, every time we compare the target element with the first element, that is 9 here. So but in binary search we compare the target element with mid element in the array. Now what is the mid element? 32. So what is target element? 58. So now we eliminate half of the array. We can check the remaining elements present in the array. Now what is the remaining elements? 45, 58, 99. Now in this 4, 5, 6, we are going to find the mid. What is the mid now? 58. Now the target element is 58, mid is 58. Compare 58 equals to 58, element found. Here how many comparisons we done? We done only 2 comparisons. If it is a linear search, we compare up to 5 comparisons. Okay, so that is a disadvantage in linear search. The advantage in binary search is, when comparing to linear search, the time complexity is low. I hope you all are understand what is the purpose of binary search. So this is the algorithm. So for this binary search, the input is array and size n. Now this is the array. So what is the n here? N equals to 7. The size of the array is 7. And we give the input target element. Let us assume the target element is 98. So target element is 98. Now initializations, set 2 pointers, low and high. We are taking 2 pointers. One is low, another one is high. So what is low? The low is initialized with 0 and high is initialized with n minus 1. What is n? 7. 7 minus 1, 6. Okay, that means low indicates first index, high indicates last index in the array. Okay, start search process. So while low less than or equals to high, that means always the condition is low less than or equals to high. Now in this case what is low? 0. Less than or equals to what is high? 6. Yes, it is true. So enter into the block and calculate mid value. So we are going to find mid here. Now mid equals to low plus high by 2. What is low? 0 plus what is high? 6 by 2. That is 6 by 2 equals to 3 now. Now what is the mid? 3. Okay. Now compare error of mid is equal to target. What is error of mid here? Error of mid is 35. 35 equals to target. What is target? 98. So 35 equals to target. False. If it is true, then we return mid value. Now, so this will be false. So again we check another condition. If error mid is less than target. Now what is the error of mid? 35 less than 98. Yes, true. So update low. So now what is low? So low equals to 0 now. That equals to mid plus 1. What is mid? 3. 3 plus 1 means 4 now. Now the low value become as 4 now. Okay. So now again check the condition. So low less than or equals to high. Yes, what is low? 4 less than or equals to 6. Yes, it is true. So again enter into the block and find mid. So what is mid now? 4 plus 6 by 2, 10 by 2. So the mid is 5 now. Mid is 5. Now this is the mid, 98. Okay, again you check what is error of mid? 98 equals to 98. Yes, it is true. So we return mid now. We return mid. So let us assume if the target element is 158. Now in this case here 98 equals to 158 will false. Then again check the condition error of mid. What is error of mid now? 98 is less than 158. Yes, it is true. So update low with mid plus 1. So what is the mid? 5. Now low is 6 now. Now what is the mid value? 6 plus 6 by 2. Again it is 6. Again you compare what is A of mid now? 109. 109. So 109 equals to 158. No, it is false. Then again you check error of mid is less than the target. Yes, it is true. So low equals to mid plus 1. Now low becomes 7. But the condition is always low less than or equals to high. Here the low is 7, high is 6. So false. So in this case we return minus 1. Why? Element is not found. That indicating that target element is not present in the array. So for example, if the searching element is 18, let us consider this target is 18 now. Now what is the target? Target equals to 18. In this case, what is mid? 35 less than 18? No. That means error of mid is greater than target. In this case, update high value with mid minus 1. Mid minus 1. So what is the initial value of the high? 6. So now high becomes mid minus 1. What is the initial value of the mid? Initial value of the mid is 3. So 3 minus 1, 2 now. The low value is 0 only. Okay. So now again what is the mid? So 0 less than 2 is true. So again 0 plus 2 by 2 is 1 now. Now mid value is 1. Now in this case 18, A of mid is 18. The target is also 18. So it returns mid value. In this case it returns 1. Okay. If the searching element is 5, then what happened? Again we are going to find low and high. Now in this case low becomes mid minus 1. 1 minus 1, 0. So mid equals to again, so 0 plus 0, 0 by 2, that is 0. And error of mid 10 is greater than mid. So again update high with mid minus 1. 0 minus 1 means minus 1. Now in this case what is low? 0. 0 less than or equals to minus 1? False. So in this case also we exit from the loop. Okay. If the loop exits and the element is not found, then it returns minus 1. Okay. So now if we give the input 98, then it returns 5. In the case of 18, it returns the index 1. If the searching element is 158 or 5, in these two cases it returns -1. Okay, so this is binary search algorithm. So coming to time complexity, the best case time complexity is if we found the searching element in first comparison, that is if you are searching for a mid value, in this case the mid is 35. If the target element is 35, then that is the best case. Now, so average case is in between, if you found, that is the average case. So let us assume 98. So 98 is average case. If you are searching for 58 or 109, that is a worst case, or if the element is not found, that is also worst case. Okay. So for the best case time complexity is big O of 1. The average case time complexity is big O of log n. Worst case time complexity is big O of log n. Now the best case scenario for binary search occurs when the target element is found in the middle of the sorted list. In this case, middle of the sorted list is 35. If the target element is 35, then that is the best case. So the time complexity is big O of 1. In this case, only one comparison is needed to locate the element, only one comparison. So average case time complexity, on average binary search reduces the search space by half in each iteration. So what it is? Now, so how many elements we have? 7. In first iteration we terminate half. Here the searching element is 98. Now the array terminate up to half, and the number of remaining elements is logarithmic with respect to the size of the input. So it is log n. Okay. So worst case time complexity, in the worst case scenario for binary search occurs when the target element is either at the end of the list or not in the list at all. If the element found in last comparison, or maybe the element not found in the list. So these two cases comes under worst case time complexity. So for this also the time complexity is big O of log n. Even in the worst case, binary search needs to examine only log n times. So why? The binary search reduces the search space by half in each iteration. For example, if there are 100 elements present in the array, after first comparison, that is divided into 50-50. That means half of the elements we can ignore. So the time complexity is logarithmic with respect to the size of the input here. The worst case time complexity is big O of log n. For binary search, the time complexity for best case is big O of 1. For average case is big O of log n. For worst case is big O of log n. Okay. So coming to advantages of binary search, efficiency, the time complexity of binary search is big O of log n. Here we follow divide and conquer. So divide the array into two parts and easy of implementations. These are the advantages of binary search. So coming to disadvantages of binary search, the main disadvantage of binary search is it requires sorted data. So requirement of sorted data. So not suitable for unsorted lists, inefficient for small data sets. Okay. So coming to summary of the session, in this session we discussed about a binary search algorithm. So binary search works efficiently on sorted arrays. So because for binary search the input is in sorted order, it continuously reduces the search space by half. The algorithm is effective for large data sets, so providing a significant reduction in the number of comparisons compared to linear search. In next class, we are going to learn about implementation of binary search. If you have any doubts, so place your doubts in the comment section. I will answer all your comments. Thank you.